For my week 7 video explainer for the first problem, I had problem 41, and in problem 41 we have a 1 kilogram physics textbook connected by a string to a 500 gram coffee cup. The book is given a push up the slope and released with a speed of 3.0 meters per second. The coefficients of friction are mu s equals 0.50 and mu k equals 0.20. So for part A, we need to solve for how far the book slides, and in part B, we need to determine if, at its highest point, the book will stick to the slope or slide back down. So before we begin, some important concepts to understand are tension, Newton's second law, that force equals mass times acceleration, as well as kinematics. And for kinematics, that's where we get this equation that we have used several times in this class right here. And so these two figures, I've drawn diagrams for the forces acting on the book as well as a separate one for the forces acting on the cup. And so for the book, we have friction going in the opposite direction of acceleration, as well as tension, the force of gravity, and normal force, whereas the cup experiences the force of gravity as well as the downward acceleration and tension in the upward direction. So now moving on to our solution, we need to solve for the total distance that the book will slide, but before we can do that, we need to solve for acceleration, but even before we can do that, we need to solve for the total downward forces. And so to start, we would start solving for the forces of the cup, which is just the mass times gravity, which is equal to 4.9 newtons. Then moving on to find the forces acting on the book. To solve for this, we will be using this equation right here. We plug in everything that we know. We get 3.35 newtons. And then finally solving for the force of friction using this friction equation. And again, plugging in everything. We are given all of these equations, or all of these values. And when we multiply them all together, we get 1.84 newtons. And then to solve for the total downward forces, we just need to add all of these forces up together, and when we do that, we get 10.09 newtons. So now that we've solved for the force, we can manipulate Newton's second law, which is force equals mass times acceleration, and we can rewrite it to solve for acceleration because we have now just found our force and we are given mass, and here it is important to note that this will be the total mass, so the mass of the book as well as the mass of the cup, and that's why we have our 0.5 kilograms here as well as our 1 kilogram there, and then our forces that we have just solved for in the numerator. And when we solve this, we get 6.73 meters per second squared for our acceleration. Now that we've solved for our acceleration, we can rewrite our kinematics formula to solve for delta x, which is the total distance that the book will slide. It is also important to note here that the acceleration will be negative because it is a downward acceleration, as it states in the problem. And so once we rearrange the equation and solve for what we know, we get 0.669 meters. And so the total distance that the book slides is 0.669 meters. Moving on for part B, we are trying to figure out if the book will stick at the highest point of the slope. And so to figure this out, we will be using the friction formula right here, using our mu s instead of our mu k. And we will plug in everything that we know to solve for 4.6 newtons. And then the downward forces here are 4.9 plus 3.35, which equals 8.25. And because the downward forces is greater than the frictional force, the book will slide back down the slope once it reaches the top.